Right guys, so today we're going to be looking at boreholes. So a borehole is basically a hole that's drilled down in the ground to see what materials or deposits are below. So you can just see there, like, as an example of a drill boring down into the ground before they start actually excavating. So we've previously seen that strata forms in layers. When building developments are searching for oil and minerals, it is important to know what materials are under the surface. So strata and outcrops can be hidden by soil layers. If no outcrop is present, exposing these materials would require expensive excavation. So you might have to go digging off 4 or 5 of these layers before you actually hit what you need. And then it might not even be there at all, so you're after wasting so much time and money getting rid of this material. So that's why boreholes are used. So boreholes can be used to investigate subsurface material. So you see the hole drilled down there. The borehole takes a sample of the material and layers beneath the surface. So there's an example of different layers of material. These samples can be investigated to reveal the depth and thickness of the strata. Right, so you have your map here again on page 10. So boreholes are taken from the surface at A, B and C. So there's A, there's B, and there's C. These reveal the points in the stratum of ore at 100, 120 and 90 metres respectively. So A is 100 metres, B is 120 and C is 90. So that's then drilled down and you can see the points where they reveal the strata. So the plane ABC represents a portion of the stratum. If extended, it will intersect with the terrain to locate the outcrop. So there's your plane. An edge view of the plane will reveal where the ore comes to the surface. So there's an edge view looking in, and it shows you your plane as an edge view. An elevation of the plane will be constructed using the altitudes of the given points in the stratum. So the same as what you're kind of doing already. Bring your points all straight up, gives you your stratum. Draw a horizontal line elevation and locate in plan. So that gives you the strike again. So in plan, this line is the true length, this is the strike of the stratum. So you all should know how to do that. We've done that already. So by looking along this true length, we will see an edge view of the stratum. So if we look along there, we see an edge view of the stratum. Now, the stratum and outcrop are seen as an edge view. The points where the edge view crosses the different heights can be projected back to locate outcrop points on the map. So exactly what you've already done. Bring your points straight down. So at the altitude of 90, if you bring the points straight down to where it hits the 90 contours. And the same for the 100, for the 100, 110, 120. So the stratum now, or the plane ABC is only a portion of the stratum. Extend the plane to locate all outcrop points. So you can extend that on further for the 80 and 130. It just makes it gives you more points to go on, and then just simply draw in your outcrop. So it's very basic. It's similar to what you've done already. So should be no problem in that. So those two questions on page 10 are pretty much the same. Alright.